Welcome to this presentation on how to evaluate the results from automated system in forensic science. I'm Timothy Bollé, a PhD student at the University of Lausanne, and Eoghan Casey is my supervisor. Automated systems are including a rule-based system and machine learning and deep learning systems are more and more used in forensic activities and in digital forensic. And one of the questions that raised is how to critically evaluate the output of those automated systems. Last year, we published a paper where we presented 3 levels of evaluations in order to do this. The first one, the performance evaluation, aims at being sure that the system is fit for purpose in regard of the question at hand and on the data. The second level, the understandability evaluation, aims at being sure that the user understands the meaning of the output. And finally, the forensic evaluation aims at drawing conclusions from the output. In the extended abstract, we present some use case scenario and give some detail on how to perform those levels of evaluation. But here I will directly jump to the recommendations. The first one is that transparency is important, but not only the transparency on how the system works, but also the transparency on how it was tested. Then we realized that users have different level of expertise, meaning that their understanding of a system will be subjective. Thus, there is a need for communication between the developers of the system and between the users to be sure that the needs of the users can be addressed by the system. Then we wanted to insist on the importance of the forensic evaluation because it will help formalize the reasoning that will go from the output of the system to the conclusion. And if this reasoning is based on some assumptions, it will help checking those assumptions. At the end, formalizing the reasoning and checking assumptions will result in more robust conclusions. Finally, and maybe this is the most important point of this presentation, is that currently the responsibility of this critical evaluation of outputs is on the user. If the user does not have a sufficient level of expertise, the consequence could be that this critical evaluation is not performed at all, or it's performed incorrectly. And this could lead to conclusions that are not robust enough, that are easily challenged by decision maker or lawyers, etc. And in the long terms, it could lead to a loss of trust and confidence in those automated systems. Now, if the systems support those levels of evaluation that we presented, it will take some of the responsibility from the user and put it on the system. And it will ensure that some critical evaluation is performed systematically. And in the long term, it will lead to more robust conclusions and more robust decisions. Thank you for your attention, and feel free to contact us if you have any questions.
Hello, everybody. My name is Spichiger, and I'm presenting a short paper called The Use of Automated Systems for Rapid Decisions that I wrote together with my colleague Timothy Bollé. We both are PhD students at the University of Lausanne in Switzerland. So what are we talking about here? Nowadays, automated systems are often used for classifying tasks. So we launch automated systems on some sort of data to sort through it for us to do some sort of analysis, grouping together elements within that data. Now, ideally, as those systems are not always perfect, the outputs of those systems are reviewed after by an expert in the field. This is, however, not always possible if there is a temporal restraint. So one scenario we're going to look at where such a temporal restraint is indeed in place is in an airport security context. The aim is to identify potentially dangerous persons that are attempting to take a flight, can think terrorists or person related to terroristic activities. So the technique that is proposed in this scenario is that we do a targeted extraction and an automated analysis of the suspect's phone, which will then give us an indication whether or not suspicious material was found on it. We are not going to take into account legal and ethical considerations, as we are more interested really in how such a system works within a context like that. This is a brief schema of what we think about. The result of our analysis is then integrated into a decision process. Sadly, we don't really have time to go into that in detail. So what factors will have an influence on our final decision, whether or not we are going to keep this person for further investigation? Well, first of all, we have unevenly distributed priors. Not every person has the same risk to be indeed a terrorist. This will depend on flights, origin and destination, as well as on the person herself. Then there's a number of system characteristics that will influence that, the performance of the system, how well the system is understood by the person handling the situation, as well as the context of the trace that we are looking at. Finally, there's a perceived risk together with organizational and personal factors that will influence how the decision is made. And all those factors are susceptible to change over time. As a conclusion, a decision does not only just depend on the automated system itself, but also its surroundings, how it is implemented, how it is indeed used and understood by those that are in charge over the final decision, how much expertise they have, and how well this expertise is applied to the current situation. And finally, organizations that aim to set up such systems should address all of those considerations. Otherwise, the system is likely to not work as well as intended or even cause damage. Thank you very much for your attention. If this presentation was of interest to you, we'd invite you strongly to read our short paper or to contact us by email. Thank you very much.
Hello, I'm Daryl Pfeif, and I'm going to talk to you about our research project introducing digital forensics in secondary school. This project was supported with funding from the National Science Foundation and wouldn't have been possible without the entire research team, our evaluators, and our project partners. We've introduced digital forensic science in a virtual learning environment. So we're both testing the curriculum and also the virtual learning itself. Our curriculum is modular, and we've tested and piloted it in a number of varieties. So summer camps, computer lab sessions, after school, and currently in a hybrid and also remote learning classroom. Our prime directive in this project was to assess whether digital forensic science and cybersecurity would be an interesting subject matter to engage more young women and underrepresented, underserved students in this field. Cybersecurity in particular has the ability to fuel systemic change, and for many of the students we hope to serve could provide a vehicle for them to escape multi-generational poverty. In addition, our project objectives were to develop the learning environment and test it. So can you really engage students in computational thinking and scientific inquiry, and how we can use digital evidence in particular to hone these skills and abilities, and also look at technology and the complex issues around technology. In addition, we have been assessing whether this can be used to increase privacy and security awareness, and I can report that the findings here have been quite strong. There is nothing like looking at the results of a mobile investigation to encourage one to be more mindful of one's own privacy and security. In our lab, we have taken an approach where we're blending really deep technical learning with the scientific principles, and also ethics and responsible use of technology. So we're doing forensic analysis and examinations, but we're having students walk through these and discuss both the ethical concerns and also look at how this data would be used in court or in the real world setting. With the guidance of our project partner, the National Girls Collaborative Project, we have refined these principles for the instruction and design of our curriculum, and have used them really as a basis to develop all of our missions, and we're walking the students through these missions in the role of investigators. The pedagogical framework is based on the IDLE model. And our virtual lab is where all of the primary curriculum is stored, and this has allowed us to really get a good sense of what resources and supports the teachers and the students are using most. So are they watching videos? Are they looking at the how-to guides? Are they doing the exercises, and kind of where are they spending their time, and which of these different kinds of resources they are using? And this is kind of to tease out how people learn in this online environment. The virtual toolkit allows us to provide access to professional tools, and also host the mission data in a way that is a controlled setting and take some of the burden of that off of our private partners. To date, we have reached well over 1,000 students directly, walking them through the education. We've got 30 to 70 hours of content. We've reached students all across the US, in Baltimore, New Orleans, Seattle, and Las Vegas, and teachers all over the world. As our project was iterative in nature and quite new to introduce both this subject material in this grade range, we did a lot of focus groups and testing and worked closely with our external evaluator to make sure that we are assessing the learning and comprehension, and we're using that data to iterate both the curriculum and add into our development process. So far, the research outcomes have been quite promising. We have direct knowledge that some of the students who were in our earlier pilots and have already moved through the 10th, 11th, 12th grade into college have opted to pursue this as a pathway. And a number of our students have also come back to us as facilitators and are helping to train and educate other students. This would not have been possible without the support of our many pilot partners and project partners. And at this point, our future work is really focused on providing more support for the teachers, expanding the role model database, reaching out to institutions of higher learning that have curriculum programs in this content area to encourage and attract more participation, and developing more partnerships with public and private universities and institutions. So I hope you have lots of questions. I'd love to answer all of them. I can also be reached at Daryl at cybersleuthlab.org. Thank you very much for your time.